Okay, Assalamualaikum warahmatullahi wabarakatuh. This is statics continuation of chapter 5. We will be covering 5.3 and 5.4 for today. Just to recap, we have covered the beginning of chapter 5 where we mainly focus on the free body diagram of equilibrium of rigid body, right? And today we will continue on how to actually calculate and solve the problem using equation of equilibrium, right? So in 5.3 and 5.4 we will basically cover equation of equilibrium, so basically nothing new except for the application on the rigid body, and also we will go into the 2 force member and 3 force member. Now in the previous lecture in 5.1 and 2 we actually have go into the 2 force member a little bit because it actually affect how you draw the free body diagram, right? Without knowing 2 force member, you cannot draw the free body diagram correctly when you have a 2 force member in the structure, right? But not sure how the slide is arranged, but we'll go yet again once again in 2 force member and also 3 force member according to the slide, inshallah. Alright, so straight into the content, right? As I mentioned in the first class, in the first lecture of chapter 5, the previous lecture, the concept is nothing new. We have covered in chapter 3 equilibrium, right? So, and also we have touched on the equation of equilibrium. Basically, we have summation of forces equal to 0 and summation of moment equal to 0, right? And so basically, what it is just when you have equilibrium, so essentially is that in the frame, yes, so basically we have the summation of all forces equal to 0, summation of all moment equal to 0, right? That is if you write in terms of vector notation, right? So if you write in terms of scalar notation, so summation of fx, for if you write for 2D, summation of f will be summation of fx equal to 0, summation of fy equal to 0, and summation of moment equal to 0, right? So you have x, y, and moment, and in total you have 3 equations. Hence the maximum of unknown that you can solve for 2D for each free body diagram is 3 unknown, right? For 3D problem, 3D free body diagram, then you have summation of fx equal to 0, summation of fy equal to 0, summation of fz equal to 0, summation of moment x equal to 0, summation of moment y equal to 0, summation of moment z equal to 0, right? So you'll have 6 equations in total and 6 unknown in total that you can solve for each free body diagram, right? So of course in 2D you do not have the z-axis, and for moment you only have clockwise or counterclockwise, so that's just one set of moment, right? But for 3D, one is you have the z-axis for the force, but also for the moment you can rotate actually for x-axis, y-axis, and that z-axis, right? Around this axis, or around this axis, or around this axis, right? So there's 3 axes that you have to consider for moment, right? So yeah, and then the slide go into the 2 force member. We have covered this in the last class, in the last lecture, but we'll cover it again just to refresh, right? So what is a 2 force member? So it is basically by definition any member that you have basically forces acting on that member only at 2 different points, right? So basically if you have some structure here where forces acting only on that 2 points, so this will become 2 force member, right? Regardless of the shape, right? It can be having something shaped like this also, right? If you have forces acting on this particular member only at the 2 point, then it becomes 2 force member, right? If you have at 3 different points, then it becomes 3 force member, right? But what is special about 2 force member is that to satisfy equilibrium, where you want to satisfy these three, right? Because this is a 2D problem, right? So it has to satisfy these three equations. So the condition must be met, that is, the force have to be acting along the line that connecting the 2 points, right? Similarly here. Only in that circumstances you will have summation of force equal to 0 and summation of moment equal to 0, right? So let's say we can have the possibility of the force in tension or the force in compression. It's either or, right? And when you solve the problem, sometimes you have to assume whether it's in tension or compression, right? Similarly here. So if you assume it's under compression, it will be like that. Oops. If you assume in the tension, it will be that way, right? So if you do not know the actual circumstances, whether in tension or compression, you just assume, and then when we have calculated until the end, if the answer is negative, that is meaning it is the opposite of our assumption. If we assume tension, then it's negative, then it becomes compression, etc., and the other way around, right? So that's two force member, right? All right, and you can imagine also, right? If because this is the only condition where summation of force equal to 0, as it's cancel each other. As a compression or tension, it is the opposite way, so it cancel each other. And also, if you have any angle from that dotted line that connects the 2 points, then you will have couple moment, right? So that's why the only condition that can satisfy the equilibrium is if it's acting on the same line. Hence, that's the special of two force member. For three force member, for example, if you have forces here also, then you do not know, right? Because then it become a general circumstances, because we will not discuss 3 force member, 4 force member, 5 force member, because all of that are general conditions where we just have to assume this is x and y component, x and y component, right? Here similarly, if it's a pin, then it's have xy component, right? So that's the special thing about two force member. All right. So now, step for solving equilibrium problem. So the slide does give you the step-by-step that you need to do. 1, establish the axis if needed. 2nd, draw the free body diagram. And 3rd, you solve by applying equation of equilibrium, right? So this knowledge here is crucial for drawing the free body diagram, and it is important to note that this chapter onwards, the calculation can be long based on your free body diagram. So if you start to make a mistake in the free body diagram, whatever calculation comes after will have the error due to the error of free body diagram. So make sure you understand how to draw proper and correct free body diagram, right? So what else? Important notes. I'm just reading from the slides. You can refer to the slide also, right? If there's more unknown than the number of independent equations, then we have a statically indeterminate situation. We cannot solve this problem using just statics, right? So in the exam, sometimes the question do ask about this kind of understanding, right? So what is the understanding here? In this, the understanding is basically simple. All right, the understanding is this, as I mentioned before, right? So if you have 3 equations, we can only solve for 3 unknown. If you have 6 equations, you can only solve for 6 unknown maximum, right? So if in any circumstances that you have more unknown than equation, obviously you cannot solve, right? Because the simplest question normally is if you have simplest in 2D basically. Well, simplest if you just have one unknown, but generally speaking, you have 2 unknown and 2 equation, right? In the chapter 3. In chapter 3, equation of particle, you have summation of fx and summation of fy for each point, right? So that's the simplest there, where of course you cannot have more than 2 unknown because you can only have 2 equation, right? So similarly here. So in the exam, sometimes they will give you certain circumstances. especially with regard to the support reaction. Right? In the last class, we have covered on support reaction on what if it's a roller, what is if it's a rocker, what if it's a collar, what is if it's a fixed support, pin support, etc. Right? So you have to know what is the support reaction there, whether it's Fx, Fy, moment, etc. Right? So different, if you notice that different type of support have different amount of support reaction. Right? If you have a pin, then you have Fx, Fy reaction. Right? If you have a fixed Fx, Fy and moment. Right? If you have a roller, just the normal reaction. So you can see that there's possibility of 1, 2 or 3 unknown. Right? So in total, the number of unknown will be different also. So sometimes the question asks, what if we change the support? Right? So initially it's pin, where you have 2 unknown, and then suddenly becomes fixed, you have 3 unknown. Right? Sometimes in total, the number of unknown becomes more than the equation that you have. Hence, you can say that, okay, in this case, it is statically indeterminate. Right? So I'll just write it. Statically indeterminate. Right? So basically, this number of unknown more than number of equation. Right? So under that circumstances, you cannot solve. Right? So normally that can be one of the type of understanding question in the final exam. Alright, so that's the first important note. The second important note, the order in which you apply equation may affect the simplicity of the solution. For example, if you have 2 unknown vertical force and 1 unknown horizontal force, then solving summation of Fx first allow to find the horizontal unknown quickly. Right? So that's that normally comes with practice. Right? Just looking at the circumstances, if you have enough practice, you can tell straight away, okay, I should start with summation of Fx or summation of Fy or summation of moment, depending on which will give you the shortest solution possible. Right? If you haven't done enough exercises, this might not be that automatic for you. Right? So make sure you do enough exercises before you go to the final exam. And important notes number 3, the answer for unknown comes as negative. If the answer of unknown comes as negative, then basically the direction of the unknown is the opposite that we assume now. So we have mentioned already in the previous lecture that when we draw, most of the time we will have to assume the direction of the force in the support reaction, because we do not know. For example, a pin, right? So you have x component and y component, but you do not know which direction is it. Is it x component, is it this way or this way, right? Y component, is it this way or this way? So you have to assume if you get negative in the end, it's the opposite. So that's basically the thing. So we'll cover the example here, and we'll see how we apply this understanding. Right. Okay, so the question given, so I'll just redraw this because it's not that difficult to redraw. So basically you have like a beam like that, and then you have a pin support here, and then you have a member here, pin there, you have another pin there, and then you have force here, which is 4 kilonewton, right? 1.5 meter, 1.5 meter, and this one is also 1.5 meter. Okay, that's basically the question. And so given 4 kilonewton load at B, so okay, I haven't, so A, B, C, D. Alright, so that's basically the question. So it says that given 4 kilonewton is acting at B, the beam is supported by pin at A and C. So here is a pin, pin and pin, right? Find the support reaction at A and C, right? If I write the question in full, find the support reaction at B at A and C, sorry, at A and C. So before you answer the question, you should already know what the question want in the end, right? So in this case, what does it want? It want to know what is the support reaction here and also here, right? So you have to keep in mind, okay, that is what I want to give. Now, what's the first step in answering after you understand the question? So the first step is to draw the free body diagram, right? Now, when you draw the free body diagram, the first question that you have to ask at this point is there any two force member, right? So if you draw the member, you can see there's two members here, one member and one member, right? So if you just draw here and then here, right? Basically, if you split the member, then you have one member and another member there, right? So yeah, the first question. Okay, of course this one is given, so we'll draw this one first, 4 kilonewton, right? So the first question is there any two force member, right? By looking at this question, can you decide, is there any two force member, right? So you should be able to tell, right? Now, this is a two force member. Why? Because for this member, you only have forces acting on it at 2 points. One is here at point C, another point is D, right? So there's only 2 points acting on the basically there's only forces acting on that body is only at 2 points. Hence, two force member. What's so special about the force member? Then we know it must be a long line connecting these two, right? So the only thing is that we have to assume whether it's compression or tension, right? But logically, you should be able to tell also, right? Logically, when you have force acting here downwards, what is the potential of this member? Is it to undergo tension or compression? Logically, it is under compression, right? Because it is being compressed, basically, pushed down like that. So if it's under compression, so we'll draw it like this, right? So let's name it FCD. Right? Now, if this is the case, right? If this is member FCD under compression, so the corresponding at point C should be like this, FCD, right? Because when you combine these two, this force will cancel each other, right? That's the logical one. So now, for this particular force, is there any angle? So you have 1.5, 1.5, so basically it's either 45 degrees here or 1 square root of 2 triangle, right? What about point A? So point A is a pin. So suppose you have AX, AY direction, right? So can you understand why you get this thing? Of course, for complete free body diagram, you have to have the dimension also, right? So this is 1.5 meter, 1.5 meter, and the angle is already given, right? So how to solve? Okay, of course, from here, if you go back to the question, find the support reaction at A and C. So meaning that we have to answer what is AX, what is AY, and what is FCD, right? So basically, this diagram is not useful for calculation. This one, right? I'm just showing for understanding of two force member and its implication on this one, right? Right. So the calculation will be based on this free body diagram basically. So you have three options, right? Summation of fx equal to 0, summation of fy, summation of fx equal to 0, summation of fy equal to 0, and summation of moment equal to 0. Which one should you choose first, right? As the important note just now stated that the order in which you use the equation can affect the simplicity, right? Sometimes you have to use simultaneous equation, but if you select properly, sometimes it's straightforward, right? So in this case, basically the thinking is like this. if I use summation of fx on this one, how many unknown do I have? Right, so if you do summation of fx, this is x component, right? So you have one unknown, and this force also have x component. This FCD have x component here, so you will have two unknowns there, right? So meaning that you cannot solve the equation straight away. Similarly, if you use summation of fy, because this is y component, this also have y component, right? So you have two unknown for that equation also. If you want to start with summation of moment, and you take moment about point A, then this one will not have any moment, and this is the only one having moment. Hence, you can solve that equation straight away, right? So let's do that. So I'll erase this one, so that we have a space to work here. So let's take summation of moment about point A equal to 0. Right? And again, just to remind that normally in the slide or in the textbooks, we normally have moment about point O, right? And hence MO. But make sure you understand that MO is not short for moment, right? We have talked about this in chapter 4, right? MO is moment about point O. So if moment about point A, then MA, right? Okay, hopefully it's not blurry, because sometimes the focus is out of focus. Okay, right? So summation of moment about point A is 0, so we only have, if I take counterclockwise as positive, so you have the x component and component of FCD, but the x component doesn't produce any moment, right? So only y, and that y component is producing counterclockwise. So FCD sine 45 degrees, this is the force, the vertical force, times the distance of 1.5, right? And then this one producing clockwise, so minus 4 kilonewton times the total is 3 meter. That should be equal to 0, right? And hence you can calculate FCD equal to whatever value that we have, right? So you can see that the selection of equation can make the solution become straightforward, right? Straight away it comes out there, right? Without the need of simultaneous equation. Now after that you can solve by using summation of fx equal to 0. So you have ax there plus FCD. I'll just write FCD in bracket here, but you should already know the value, and the value should be there already, right? So FCD cos 45 degrees equal to 0, right? So FCD will be something. In this case, it will be negative something, right? Because if you calculate this, FCD will give you a negative value. And what does it mean? Meaning that, sorry, not FCD. I made a mistake there. So AX should be equal. AX should equal to negative something there, right? So what does it mean? It means that AX is actually to the left. That is what it means, right? Summation, and then summation of Fy equal to 0. You'll have AY plus FCD sine 45 degrees. Again, FCD here, the value you already know, and then minus 4 kilonewton equal to 0. And then you can get AY equal to a certain value there. So depending on the value, if it's a positive, then okay, our assumption is correct. If it turns out to be negative, then the direction is downwards, right? So if that happens, you actually should notify that, oh, this means it is to the left, right? So that you specify your understanding, that you know what this negative means, right? If you do not do that, it can mean either two things, right? Do you mean actually the value is negative Newton? Because if you say the value is negative 4 kilonewton or something, that does not make sense, right? Because force cannot be negative magnitude. The only way, meaning the understanding of this negative, is just because the opposite direction, right? Because we have, for example, this one is to the right as positive actually, right? So it means just positive and negative is the direction, right? Alright, so that's how basically we solve, and the answer is also in the slide, so I'm not focusing on the answer that much, but only for the steps, right? Hopefully you understand the steps. So according to the slides, for AX and AY both will get a negative value if you assume to the right and upwards, meaning that AX is actually to the left and AY is actually downwards. But FCD is actually correct, this assumption, because logically this one will be on the compression as we have assumed, right? Yes, so and the answer will be AXAY and then FCD. Hopefully it is understood, right? Hopefully you understand this example. Okay, so we will go straight to the next example. Right, group problem solving. If you see the slide, it's have the title group problem solving, and then you have this problem here. So I'm gonna erase this and draw the problem. Alright, here you have basically also a distributed loading, right? So something like that, where you have a pin support here, and then you have a roller here, and then you have distributed loading here. Where this is 3 kilonewton per meter. Oops. And then this is distance of 4 meter. This is 30 degrees. And then this is 3 meter. Right, so that is the question there. So we have basically the beam here, and then you have the support of a roller over there. Over here, this is roller, this is pin support, and then this is distributed loading. So the question says, find the reaction at point A and B. So where is point A and B? So this is A and B. So basically you have to find what is the support reaction here and here, right? And by now you should be able to tell, right? What do you have here? It should be a normal reaction, right? There's a roller. What do you have here? You have Bx and By, right? So in the end you have 3 unknown. So how to solve this? Of course, first is free body diagram. In this case there's no 2 force member, right? There's only 1 member there also. So basically if you draw the free body diagram, you just draw the outline of the shape there. So it's something like that. And of course if you focus first on the distributed loading, so the force will be at the middle, right? So it will be something like this. Oops. At the middle, meaning that 2 meter, 2 meter. And the value should be just the area of the graph, right? So that's 3 times 4 kilonewton, right? Or 3 kilonewton per meter multiplied by 4 meter, you get basically 3 times 4, which is 12 kilonewton. And then you have the support reaction here, which is a normal. So this is, let's say, NA, right? And then okay, the way I draw it is exaggerated. So this one is 30 degrees there, right? Based on this 30 degrees here, right? And what else? So what do you have at B? You have, let's say, Bx, By. So we will assume that direction there. Bx to the right, By upwards. So that will be the figure. Okay, not complete. So we have here 30 degrees and then 3 meter there, right? Again, for free body diagram, it should have all the information, the forces, the label, the distance, the dimensions, etc., right? Right, so now you have three equations. Again, summation of fx, summation of fy, and summation moment. Which one will you use first? And hopefully the logic that I told you just now, you can think about it, right? So if you take x component, obviously just x component here and x component there. Y component you have here and there. But if you take moment about point B, you are left with only one force, and hence you can solve straight away. Right? So that will be that will be the thing that we choose to do. So summation of moment about point B is 0. So if I take counterclockwise as positive, right? So moment about this one. So counterclockwise, this one is 12 kilonewton times the distance of 2 meters, right? So then this one is here. What about this one? So this is quite interesting because you have this distance at an angle there, right? So what you need to do is, if you can straight away imagine that's fine, that's okay, that's great, you can just calculate. If you need to draw to make it clear for yourself, especially in the exam, please do so, right? We do not want to make simple mistakes, silly mistake in the exam, right? That's important, right? So basically, if you consider the vertical component, right? So the vertical component is going to make a clockwise rotation, so minus, and the vertical one is what? NA cos 30. So NA cos 30. That's the force vertical here, right? So the distance will be what? The distance for this vertical will be this whole distance here, right? Which means this 4 meter plus 3 cos 30 here, right? This distance, right? So we have 4 plus 3 cos 30 degrees, right? Hopefully you can imagine that. So this, because the distance is this total, and then the horizontal force is still clockwise, so minus and A sine 30 degrees. That is the horizontal force. The distance will be just this one, right? So it will be 3 sine 30 degrees. Should be equal to 0. Right? And from this, you can straightly calculate NA equal to something. Right? And hence you already solve what is the NA. Right? Hopefully that is clear. And if something is not clear, please do draw what you need to draw, right? For example, if you draw, you just draw this x component. Okay, do not draw on your free body diagram, right? This is okay. My comment here is for the exam purpose, right? For the exam purpose, your free body diagram will have its own mark, because that is what you need to show that you know how to draw. To draw the free body diagram, that's one of the learning outcome, right? So you draw the free body diagram already, right? And when you want to calculate, if you need to draw something, do not draw on the free body diagram, because if you draw something like this, in terms of free body diagram, that it means you have 3 forces there. You have 1, 2, 3 forces there, right? Which is not correct, because the red one there is just for your calculation, right? So draw it separately, right? So that the free body diagram will be intact as a free body diagram, and will have your full mark there, right? So yeah, that's a comment for examination. So what I'm going to show here is no longer a free body diagram, because I'm just illustrating how do you calculate this one, right? So when you have this vertical and horizontal component, which is, of course, this is NA cos theta and A sin theta here based on this theta, or 30 degrees. This vertical one have this distance, right? When you draw, it becomes obvious, right? So this one, or this is obviously the perpendicular distance. And if you have the horizontal force, if you prolong it here, so this is obviously the perpendicular distance, right? So hence the perpendicular distance, using this 3 meter, you have 3 sine 30, this one 3 cos 30 plus this length there, right? And hence you get this one, right? So hopefully you understand what's going on. Alright. Okay, we haven't finished yet because we haven't calculated for bx and by, right? So what do we do next? Obviously, just where do I write this? Okay, I write it here. So if I continue here, summation of fx equal to 0 to the right as positive. So we'll have bx plus NA sine 30 degrees equal to 0. Right? Obviously, this NA is already solved. You have the value there, so you have bx equal to whatever answer there, right? And then you do summation of fy equal to 0. So obviously you have by, and then you have minus 12 there, and then you have plus, you have an E value cos 30 equal to 0, so by equal to something there. Oops. Right, so I hope you get the drill. I hope you get the steps by step. The step is actually simple. Draw free body diagram, 3 equation of equilibrium. Again and again, that's the only thing. However, as you can see in this example, it combines some understanding from different chapters and different subchapters, different sections, right? For example, here you will have this distributed loading, so you have to understand how distributed loading can be calculated into equivalent force and where it is, right? Because for example here, right? So this 12 is the force itself, and this 2 is the location, 2 meter. If you make a mistake in terms of putting the location of the force, then hence the calculation of moment will be wrong, and then this answer will be wrong, and then it will affect this one, affect that one also, right? So do not do that. Do not make a mistake like that, right? So make sure you understand distributed loading, especially the rectangular and the triangle. Where is the location and how to calculate the value, which is the area, right? So another thing is the distance here, right? So this distance just requires some trigonometry understanding here, and you can visualize the distance like this, right? So the step is simple: free body diagram, some equation of equilibrium. That's the only steps. However, to get the free body diagram correctly, it already combines some understanding, right? So that's what I want to try to say. Okay, so alright, so we can solve, etc. So if according to the slide, that's it basically, because we only have, the slide do not have that much exercises or example. It just cover enough example for you to understand how to apply the concept, right? So but in the class we actually cover several examples, and we have covered the class for by now. If you are watching this one, normally you have already covered in the class how to draw the free body diagram for many different diagrams, right? So if you missed that class, you can watch the recording of the class session in the playlist, right? So look at the playlist for the class session. Normally it's the course code and then which semester, and then you can see that, right? For another example, many other example of 2D equilibrium problem of of rigid bodies, it will be the class that comes after this lecture, right? So if you just watch this late on after the class have already done, so you can also see the exercises that we cover in the class for different type of problems for 2D rigid bodies in equilibrium, right? So make sure you watch all of those. Try some other examples, try some other problems in your textbook. If you have any question, you can ask down in the comment section or in the class as usual. Please do ask. Make sure you understand. And with that, I think we'll end the session. We'll end the recording here. And next, we will go into 3D. right? So yeah, again, I forgot to mention, in the previous lecture we have covered different type of support reaction. So here we do not cover that much of different type of support reaction. We only cover, for example, this is pin, and this is pin, this is roller. Because if you understand what you have covered in the first class, whatever type of support reaction you can already, whatever type of support, you already know how to draw the free body diagram of its support reaction, right? And if you already have the free body diagram settled, the equation of equilibrium is just a normal equation of equilibrium, just summation of Fx, summation of Fy, and summation of moment. You just apply to all of the forces and moment that you have, right? So there's nothing new there. But my point is, do try different type of question so that you know how to draw the free body diagram for different type of support action, and also you can try until the calculation end. With that, thank you very much. See you in the next lecture, inshallah. Subhanakallahumma bihamdik, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Wassalamualaikum warahmatullahi wabarakatuh.